Hello, Year 9. So today's lesson continues on with yesterday's, where we looked at volume of a pyramid yesterday. Today we're looking at the volume of a cone. So a cone is kind of like a pyramid, except it's got a circular base. It still meets at an apex. It just means the faces are not triangle faces, okay? It's kind of this curved edge. Where this time the base is just a circle shape. So remember, our circle, the area for a circle is pi r squared, where r is the radius from the center, and this h in height represents still the perpendicular height where it drops down from the point through to the center of the circle. So that connects to the radius because that's where the center comes from. This edge is called the slant edge, or a slant height, I guess. So again, be wary of that language. So the first question, calculate or find the volume of the cone to the nearest centimeter cubed. So here we've got the cone that we're finding the volume for. We need to find, first of all, remember the area of the circle. So with this area of a circle, it's pi r squared, where r is for the radius. With our circle, we've only got the diameter. So our diameter, as you can see, remember, goes from each side. That's 21 centimeters. So for our radius, for r, that's half of the diameter. So half of 21, which is 10.5 centimeters. So that's what we're going to use for our r value in our area of a circle. So for the volume, it's equal to, remember, a third times the area of the base, which is a circle, times the height. So we've got a third times pi r, which is 10.5, pi r squared, times the height, which is 30. Okay, so this comes from the area of a circle, which is this guy, and then the height, which is 30. Putting that into your calculator, you get 3,463.6059, etc. And because it's to the nearest centimeter cubed, it would be 3464 centimeters cubed. All right, last example. A cone has a slant edge of 61 millimeters. So this isn't the perpendicular height, okay, because that would be that height. This is the slant edge. So imagine that edge that runs down the ice cream cone. And a base radius of 11 millimeters. Find its volume correct to 1 decimal place. So for this guy, this isn't the height that we want for our circle, for our volume formula. We actually want, this, right? Like that's our height. So from this, as you can see, what this has created is another right angle triangle. So pulling that right angle triangle out of our cone, we've got 61 millimeters on the hypotenuse. This is 11. And then this h value is going to be that height. So we can use Pythagoras' theorem of c squared equals a squared plus b squared to find out our height. So this time c squared is 61 is equal to h squared plus 11 squared. Remember, we want h by itself, so we subtract 11 squared from both sides. And that gives us 3,600. But we don't want h squared, we just want h. So remember, you take the square root. And again, like yesterday's, it's kind of like the plus or the minus, but because it's a distance, we only want the plus version, and that will give us 60. So now that means our height is 60 millimeters, and we can use that for our volume. So our volume, remember, is a third times the area of the base times the height. So we've got 1/3 times, remember it's pi r squared. So pi r squared, where r is our radius, and it already tells us the radius is 11 millimeters. So pi times 11 squared times the height, which remember we just found is this guy, which is 60. So times 60 equals 7,602.654, etc. And we want to 1 decimal place. 1 decimal place. Wow. 7. And it's in millimeters cubed. And that's literally it. There you go. Nice and easy for you. Good luck.